Hello everyone, welcome to this advanced mobile penetration testing webinar. So, before starting our webinar, I would like to introduce who are we, the Cyber Sapiens. Okay, so we are cyber security experts committed to securing the digital world, and we are located in Mangalore, Bangalore, as well as in Australia, Canada, and the USA. So, we are cybersecurity experts, and we have the services for businesses like ISO certified. We are ISO certified company, and also we provide certifications for other companies. Then we have the VAPT service, which is mainly on web VAPT, network VAPT, mobile VAPT, API VAPT, as well as infrastructure VAPT and cloud pen testing as well. So other than that, we have the SOC analysis and malware analysis on as a service for businesses. Then we also provide the GRC service, phishing and malware simulations for the companies which they are looking for. And we have our own product that is a fish care that which we mention as your first line of phishing defense. So these are our services, and we have another service that is mainly on cybersecurity training and employee awareness. Okay, so to know more about our service or about our company, you can visit cybersapiens.com.au, or you can scan this QR code to know about our company details. So let's begin with the advanced mobile penetration testing webinar. And here we're gonna explore the exploiting of real world vulnerabilities. So before that, I'll introduce myself. I am Abdul Rameez, a senior security analyst at CyberSapiens. And who am I? I'm a certified ethical hacker, certified mobile pen tester, and also a certified app practitioner. And uh, I have good knowledge on red team and VAPT. Then I also do training and mentoring for the trainee interns who needs guidance on the cyber security. Then also I provide the consultation for the clients mainly on security purpose, on how to fix the vulnerabilities, all these things. Then also I do bug hunting. It's mainly as a freelancer. I just work on the some of the VDP targets, or it could be in HackerOne, Bugcrowd, any of the targets, and I report some of the bugs which could be which got some of the bounties, Hall of Fames, and all. So yeah, let's see the agenda of today's webinar. Okay, so everyone wants to know what would be the agenda on these topics. We'll see the introduction to the advanced mobile security threats. That's the first thing. Then we'll have a deep dive into mobile security architecture. So architecture, it's about how the mobile applications has been secured and all those things. Then we'll have some real world case studies on the vulnerabilities which are exploited, and it's mainly about the attacks that has been happened in the past and all. Then I'll show some of the tools which are used for exploitation as well as for for testing a mobile application. Then we'll be moving to the advanced reconnaissance techniques, which could be the practical way how we can find the loopholes in the mobile APKs, or mobile APKs or IPA files. Then we have the exploiting the common mobile vulnerabilities, which will be alive on how we can find some vulnerabilities in the mobile applications and how we can bypass it, how we can check the informations, how we can uh, get the details, all these things. Okay, mainly we'll be seeing the exploitation part. Then regarding we have the reporting and compliance part. Okay, just reporting, it's mainly on how to report these vulnerabilities, and what type of compliance part we have to follow when we do reporting, all these things. So we'll move on. These are the agendas which we're going to cover in this webinar. Okay, so let's go on to the first topic, that is introduction to advanced mobile security threats. Okay, so what are advanced mobile security threats? As see, the mobile security threats refer to the modern sophisticated attack techniques. Okay, it's mainly the target. It's about the targeting the mobile applications or devices, and you see nowadays. Mobile is not just a communication wireless for us, right? So we use our mobile devices for various purposes, for paying, for sending amounts, or it could be for storing our personal data, storing our credit card details, or a lot of things we do through our mobile phones. And regarding this, a lot of attacks also, there are a lot of security threats are present in the mobile application. See, we cannot say that every device is 100% secure or every application is secured at all. So there could be some loopholes in the applications where these criminals target these applications or mobile devices to find specific information of the victim or the uh, yeah, mainly about the victims, or could be the application servers and all. Okay, so let's these are some advanced about mobile security threats. Well, let's see the emerging threats in the mobile landscape. Okay, the one is spyware and malware. It's mainly about the malicious, as you know about virus. Same way here also, some of the malicious application which will steal your information silently in the background. You don't know when it was installed, and it could be installed by some other people or your friends, anyone. Okay, these malwares or spyware, which will be installed automatically, and it will be running in background where it sends your data to the other users. So like that attacker. Same way we have the another threat, that is zero day vulnerability. These vulnerabilities, like which are unpatched vulnerability, and it can be exploited before the developers are aware. Okay, so developers don't know these vulnerabilities are present in the application by some code issues, or some, if they are using the old code methods and all, which could lead these vulnerabilities. Same way we have the another threat, that is phishing via mobile apps. That is mainly we call it as phishing, where tricking users on revealing some credentials or some more data, where you I think, I hope you guys got a lot of these phishing messages, like you get a job or you get some emails, okay, mentioning that these are some of the jobs you got. These are like you got around $10,000 or 10,000 rupees in your bank account. Just to claim, you have to click on that links. These are smishing or phishing attacks. Okay, so mainly this happens for the mobile applications, because the attackers know that everyone uses phone nowadays. Everyone has a phone, and because of that, these attacks are highly done by the hackers to get your details and all. Okay, where you tricked into that and you fall into that their traps and all. Then we have the another threat, that is reverse engineering of APKs. So where this reverse engineering, it's mainly about converting the application, where we'll be decompiling the application and analyze the code with to find some weakness, and make it in a different way, where we're adding some extra codes to reveal the contents of the user. Okay, adding extra server URLs, where the hackers can see your data. Like, the WhatsApp is encrypted, right? So every chat is encrypted, and one of the WhatsApp is there, like GB WhatsApp, OG WhatsApp. A lot of WhatsApps are there, and some WhatsApp, like you think that it has a lot of features, we can use that type of WhatsApp and we can share our data, but you don't know that the chat which was encrypted, it can be breaked, and your data is sending to the attacker's mobile. Like if you're doing a video call, if you're sharing some data, confidential data, credit card details, so that can be seen by the hackers. That's where reverse engineering can be a threat for the it is a threat where the hackers deal with it. Okay, and same way unsafe third-party SDKs, like some of the poorly some of the SDKs or libraries which has been used by the mobile applications. Mainly they use these frameworks on the application part, and it could leak a lot of data. Okay, so if it is a vulnerable third-party SDK, it could leak the data, and which allows the hackers to attack that on that particular mobile application. Same way, abuse of app permissions. Like some of the app permissions are not needed for the mobile application. As you know, see, if it is a weather application and it is asking for the app permission of your contacts or call logs, or it could be your yeah, mention this mainly about your photos and all. Okay, the storage part. So it doesn't need that access or location. Location mainly it's needed as per to check the weather, but see, it doesn't need other access and all. So these access mainly mentions that it could be the threat, or it would be the application done by the hackers to reveal your details and all. Okay, so this type of permissions are one of the threats that lie in the mobile landscape. Same way we have the man in the middle attack. So interception of data transit over the public Wi-Fi, where you enter your credentials in the mobile application and you connect it to a, like open Wi-Fi, okay, which where the hackers could easily get your details by intercepting the data or sniffing the data, like what you are transferring. And you do know that when you connected the Wi-Fi, the data which you transfer, like which you enter in your phone, has been transferred with the and in, like in a decrypted way, okay, not encrypted. It will be in a plain text, and the hackers could get these details, okay. Then we have the another method, like clone apps or fake app stores. Like some of the fake application stores are there, which is of distributing some fake versions. Like most of people go for the CapCut, okay, nowadays video editing applications, and they mention that okay, the CapCut, we got a premium version and fake versions. Like you don't see that these applications could be a threat for your mobile application, yeah, mobile device. And you see that oh, it has a premium version, we'll install it. When you install that application, that particular device, your device will be hacked and infected by some virus, and these applications will transfer your data to that particular hacker. Okay, this way, these are some of the threats that lie on the mobile landscape. So we have to be see that how we can protect these and how uh, to find these loopholes on the mobile applications. Okay, so let's see how the importance of proactive mobile app security testing is needed. Okay, so why security testing is crucial? One of the thing is most apps are developed with the focus on feature, not security. See, the developer, what they do, they build the applications just checking for the features. Okay, we add these features, we had these buttons, it could look very good with the some fancy types of the icons, all these things. But the thing is, they forget to add the security codes. Okay, the security, they doesn't review the code, you just add the code, and they think that it could be fancy looking designs and features and all. But the thing is that the developers, they forget that there is no security on the mobile application. One of the thing is, for that reason we need the mobile app security testing. Then same way we have another thing is about one of the small vulnerability can compromise the user data and also the company reputation. See, one vulnerability can be found in a mobile application, which could lead like the company or the users. Okay, the users never trust that applications. It will be mentioned that this application is vulnerable and our data is not safe. So based on that, people won't believe on the company's uh, on company, and also their reputation will be very down. And nowadays threats evolve rapidly. It could be any types of threat, as I explained in the above slide. And some of the vulnerabilities, like what was safe in the last year, may be insecure today because of some ways where hackers found some of the good ways of hacking tricks, or it could be some codes which had a vulnerability, and the hackers had the way to find these vulnerabilities and all. Yeah, so that's why the proactive testing, mobile application security testing is needed on the yeah, most of the applications. And also let's see the benefits of proactive testing. Okay, so regarding proactive testing, we need to find the vulnerabilities. Like it will help us to like when we build the application itself, for the developers, as they will have the idea, like finding the vulnerabilities in the early development stage when this application is built. And also it will prevent the data breaches of, it could be the financial loss, or mainly on the it could be on the legal trouble as well. Okay, where our data is not leaked, our users data has been not leaked and all. Same way builds user trust by ensuring the app is very secure. Like when the application we download from Play Store, we believe that the application is very secure, and we think about, okay, this is a secured application and we could use it. Okay, so based on it will build that trust with the users and the company. Same way, it will be meeting the compliance standards. Okay, so every application, every the digital application, which should be followed with the compliance standards like GDPR, HIPAA, or PCI DSS, which mentions that these applications are very quality application, and we can download this application and we can use this for further usage and all. It could be any types of application. Okay, for this purpose, we need this proactive mobile application security testing, and these are the benefits we can do on the testing part. Same way will in the testing part, okay, where it includes like static and dynamic analysis. Okay, so where we'll analyze the applications, how it works, and it could be the application source code review, or it could be the dynamic analysis in the runtime way, where we'll see the application, how it works, how the workflow to the server, and all the content part where we could identify some loopholes through that also. Then we'll test against the OWASP mobile top 10 vulnerabilities, like some of the like we have a set of OS mobile top 10. Like OS mobile top 10 is about open worldwide application security project, where it provides the top 10 vulnerabilities found in the all over the world, okay, in the mobile applications. And it is a community that will help the developers as well as the security researchers. These are the top 10 vulnerabilities where we could go test on their by just checking these OS top 10 vulnerabilities and all. Then we can go for the secure code reviews, where we have to identify each code values, how it has been written. Based on that, how the data is encrypted. It is using a high level cryptographic encoded method, or it is using just a simple encoding method for securing the data and all. So we gonna check review the secure codes as well. Okay, then we gonna check the API security testing. Mainly API security testing, why I have included, it's because see, now mobile applications, it is interconnected with the API for API calls and all to send the data to the server. And most of all these applications will be linked for the API calls. So we will be using we will be doing the API security testing on the application part, and we're gonna find some loopholes on the target. And we also analyze the binary analysis of the mobile application, the SIG codes, as well as the reverse engineering part of the uh, mobile application. So these are some of the uh, yeah, testing part, where we gonna test the mobile application and find these loopholes. So let's see the mobile security architecture. Okay, so how the mobile is secured, or could be the mobile, mostly mobile, how the application runs and all. So first thing is about a secure boot. So secure boot, it mainly it's about the applications that it is very secure. Okay, only booted with the particular verified software. Like if you're installing some other softwares, or like the OS on the mobile application, it will not it will not allow you to install these other softwares in your mobile applications. Okay, and it will prevent from malware or unauthorized OS modifications, and also from loading during the startups and all. Mainly in the Android part, it uses a verified boot to check every boot stage with the cryptographic signatures. Like if it is actual OS, like you are installing, if it is a actual firmware you are installing in the Android device and all. Same way with the iOS, it uses a chain of trust. Okay, chain of trust. It is mainly about one of the boot process that done by the Apple, and it is about the Apple sign code. Okay, it will be verified by that, and it checks that these application, the software, or the firmware which we are installing on the application, if it is secured or not. So benefit from this, it will protect against the boot level malware and the rootkits that we install in the mobile application. So it will be protected from these attacks and all. So next, we'll have keychain and encrypted storage. So here in the keychain and encrypted storage, we have the mechanism. It's the mechanism of storing the sensitive data securely. Like, see, you store your data, like you put a lock on that, right? Same way, here also these are the keychain, like which provide some way where your data is very safe and protected. It could be any types of data, passwords, tokens, certifications, credit card details, anything. Okay, so in Android, we have this key store system for to store the cryptographic keys in a secure container, and it's like it will store your data in a single container, and all these will be with the cryptographic keys, and it couldn't be able to easily decrypt that data. Okay, and data is encrypted using some of the way, that is TE, trusted execution environment, which is a hardware backed storage which will protect our data. Same way with iOS, we have keychain services API to store credentials, and these keys are encrypted and linked to the user's biometrics. See, iOS, we know that it is secure, and by this our data is very safe and secure because of our biometric as well as our iCloud passcode lock, and our data is very encrypted way where the data like the hackers couldn't get these data or they cannot decrypt the data clearly. Okay, so benefit of these keychain and encryption storage, it mainly ensures that data remain protected even if the app is compromised. Okay, if the app is also vulnerable, we could see that our data is safe and it is not shared to anyone else or by that application also. Okay, same. We'll go ahead with the apps unboxing. So apps unboxing here in the sense here each one of the application which you run when you open an application, it owns an isolated environment. Okay, it creates an virtual environment for its own to run. Okay, where it will prevent the apps from accessing data from other files or other applications. Like you see when you give some when you are trying to give some access to applications, right? It will ask allow or deny. Okay, that's the permission you're giving to that application. So this application can access the permission for like files from storage and also which you have assigned to that. So because these applications are runs in a single environment and where it cannot directly access it, if you are allowed to, if you are given you know, yeah, permission to that, it can be viewed and all. Same way, like for Android, it uses the enforced of OS level using UID based sandboxing, and this sandboxing will have like a unique user ID where each app runs with the different user IDs, and it will it have its own environment. Okay, same way we have the iOS. So iOS uses app sandbox with the strict it mentions like entitlement rules. So regarding entitlement rules, like see in iOS, whenever you open the applications, it doesn't go for the other applications permission. Without giving a permission, it never even access the camera as well. So it runs with a single app sandbox. Only that particular environment will be running that application, and the other application will have a different environment to run that. Okay, it will you're using a single phone, but you have a different environment, virtual environment, which has been created by this app sandbox in your mobile phones. Okay, so benefit of these where it will prevent from unauthorized access between apps where it couldn't get your data or it could be storage anything from the application part. Then we'll be having the SC Linux. So it's mainly for Android specific because like see, it is a security enhanced Linux mandatory access control system built in for the Android part. Okay, and regarding the purpose of this defines like the policies for the applications, system resources, how to use, what type of process can access, and also what type of apps can run on all these things are defined by this SE Linux. And if the app is compromised, SE Linux will prevent it from doing further harm on the applications. Like if one of the you have installed one of the application on your device and it is a vulnerable and it could cause the other application to reveal some data, but through this SE Linux, which is a security enhanced Linux, which will help your data will be very secured and it can be prevented by this security part. Okay, then the benefit of this, which adds an extra layer of defense beyond the standard sandboxing, and will protect you from sharing the data to other applications and all. Okay, so yeah, we have another thing that is secure enclave that is in iOS, and we have key store in Android. So both are usually used to safely store your managing cryptographic keys like your datas, or it could be your fingerprint face IDs or app encryptions, like you put a password to your applications. All these things will be stored in this secure enclave and key store. Okay, so a secure enclave, it's mainly a separate hardware chip isolated from the main processor, and it stores the biometric data and encryption keys, each password, each keys, each like the lock you put in your mobile application will be stored in this part. And if the even iOS is compromised, the secure enclave stays protected, and it will like detect, it will keep your data very safe and all. Same way with the Android, we have the key store where it creates a container where it like a system level container for storing the cryptographic keys. They all like your biometric, your the pattern, your password, all these things. And it also uses the same thing, that is a TEE, the hardware backend backed security, and whenever it's available. Okay. And it's not isolated by a separate chip like never like expect on some newer devices. But it has some main features, like which your data, your fingerprints, all these data are very secure. Okay. So these are some of the mobile security architecture. Then we'll move on to the jailbreaking and routing part. So I hope you guys know what is jailbreaking and routing. And let's see, the jailbreaking, it's about a process where you will uh, remove the built-in security restrictions. Okay. So it's about like gaining the access to mobile device directly and getting the deeper access of the OS. Like you are entering into a deep ocean. Okay. And getting the like to seeing other fishes which are not even, which we are not able to see in the upper level of sea. You're entering where in the deep ocean you can see other data, right? Same way here also we can see that. And in the jailbreaking OS, it removes the Apple security controls. Okay. Where your datas, okay, it doesn't have these security policies which was given by the Apple. It will remove that, and it will allow the installation of unauthorized application or fakes, any of the other firmwares which can be installed in the iOS. Same way bypasses App Store and sandbox restrictions, like which was secured, which has a security uh, controls which was given to the mobile application. It will remove these by jailbreaking your iOS device. And for routing, it's for Android part. So where it grants the main file access to Android system files, and also you can do any modifications to system level setting, install some custom roles, firmwares, anything, as you have removed the security part, and you can get the access to these files and all. Okay, so the security implications on the mobile device when you do a jailbreaking or routing, so increases a risk of malware, data theft, and the system instability. And also like your data could be theft by, like it can be stolen by the hackers, or any types of malwares can be added. And also it disables the key security layers like secure boot or sandboxing, and it can be used any types of custom ROMs can be installed. And also another thing is it voids your warranty and breaks official security updates on the mobile application. You will not get the updates which you were getting by the mobile server, like yeah, mobile devices. But it will be removed, and you will also get the warranty of the mobile device will be voided. Okay, so yeah, these are some deep idea on the mobile security architecture. We'll see some of the real world case study of mobile application vulnerabilities. Okay, so the first case study, it's about TikTok. Everyone knows TikTok Android application. And it is mainly nowadays we have the reels and all, right? Everyone you we watches reels and shorts, same way with the YouTubes and all. Same way we have this TikTok application which was there, and it was banned in India. And regarding this, we had a vulnerability, web view hijacking vulnerability. Okay, so the vulnerability summary, it's made in 2022. One of the Microsoft researcher, okay, he discovered that web view. Explain what is web view. Okay, so it was hijacked, web view hijacking vulnerability in the Android version of TikTok. So the issue stemmed from improper usage of JavaScript. Okay, so in what one of the API call was there, which is of JavaScript interface, and where this attacker, or they say this security researcher from Microsoft, he has found that by this API call, where he could inject or execute some arbitrary command over the JavaScript, and do some activities on that. And regarding the discovery and exploitation, in the app view, embedded web view. Okay, so web view components in the sense in the mobile applications, if you are viewing if you want to view the content of what you say, mainly it's about your your web applications or codes like privacy policy, or it could be web application page and all. The mobile app contains these web view components. Okay, and this it had a some insecure configuration on the web view component, and the attacker could craft a malicious link on that. Okay, so this attacker, this not an attacker, he's a Microsoft researcher, a security researcher, very crafted a malicious link on that. And when opened a TikTok web view part, okay, when we click on that privacy policy or any of the thing on the TikTok application, it will allow the remote code execution within the application context, and which could lead the unauthorized access to users account data, profile editing, and context manipulation, anything like he can delete the user's account or content, deleting other contents, and all these things can be done by this just one of the web view hijacking vulnerability. So regarding this, we had some like remediations has been done by the TikTok. So they have released an update for after responsible disclosure by Microsoft, and also they have followed the secured guidelines for web view usage, where it was evaluated and fixed the vulnerability. Then also they have binded where the JavaScript interface, which was used for the web view content, and were reviewed and are coded by the uh, TikTok security. Okay, so regarding source, you can check this Microsoft security blog on TikTok vulnerability, and you'll get on the idea on this case study. Same way, we have another case study. It's mainly on Starbucks Starbucks iOS application, and everyone knows what is Starbucks, and everyone wants to have the one time you want to have this Starbucks coffee. And okay, so we had this application. It also has application in Android as well, but in iOS there was a vulnerability, that is insecure data storage. Okay, insecure data storage vulnerability. I hope you have seen in the last basic class of the which was done by Kuldeep, and he has explained how the insecure data storage vulnerability occurs. And same way here also in the Starbucks application, this iOS application had a vulnerability. Okay, so in this vulnerability, the vulnerability summary, it's mainly on in like in 2014, one of the security researcher found that Starbucks iOS app, okay, it stores the user credentials. When you log into application, your user data, it's in stores it in a plain text, okay, within the app's local storage. So the data includes email address, password, geolocation information, mainly your location history as well as your address. All these data were leaking in the as a plain text in the local storage, where the hackers, okay, the exploitation part, the issue was discovered during static analysis of the IPA file. So why it has mentioned like static analysis? So static analysis is one of the applications when they were checking the code and analyze that. So data is not encrypted of the in the application, and it has been stored in a simple way on the mobile application. So which help the researcher to identify, okay, when he check the code and he identify that he log into the application, then he identify that the data is not returned and sensitive data has been returned to an unencrypted crash log file, and it was saved in the local storage without with the plain text format. Okay, so if the user device is jailbroken or accessed physically by others, data could be extracted easily on this vulnerability. Okay, so these are some exploitation was done on the Starbucks. Same way, the remediation has been released by the Starbucks application, the company, and Starbucks released a patch on how to acknowledge the vulnerability. Then they have introduced the end-to-end encryption for all sensitive data storage, where implemented secure code practices, so like how the data's code has been written and how the data should be secured and all. And same way, they have highlighted the importance of authoring the OS mobile top 10, and providing like taking that this they are protected from the all the top 10 vulnerabilities which was mentioned in the OS mobile top 10. Okay, so, and sources for this you can also go for the computer world, Starbucks app flaw, which to know more about this case study. And yeah, we'll move on to the tools used for the exploitation on the mobile pen testing. When you do a pen testing, when you do a security testing on the mobile applications, you need these tools. Okay, one is APK tool. We need JADX tool, MobSF tool, ADB toolkit, Uber APK signer, APK lab, 3U tools, imaging, and 3U tools imaging is for iOS. Burpsuit, it can be used for iOS, Android, same thing. Okay, and Frida custom Frida scripts are there, which are mainly needed to bypass a lot of runtime manipulation techniques on the mobile application. Then we have the browser exploitation, which is a good, very high level tool for exploitation of the activities, contents, components, or yeah, most of all, lot of details can be identified the browser tool. Okay, and also MobSF. If you guys have installed it in your Windows, only APK can be tested. If you have installed in the Linux environment, you can test iOS as well as like IPA file or APK file. It's like regarding the APK file, APK it's mainly for our Android device, and if you're using for the iOS device, you need the IPA file. Okay, yeah, let's start with the practical part, which will be live on the part, and I'll be showing some theory part as well as the live, where you could get some idea on what type of vulnerability we are going to test and all. Okay, so let's begin with the advanced reconnaissance techniques. So recon in the sense it could lead to some information disclosure bug as well. Okay, reconnaissance in the sense it's about gathering the information, and we know how to gather the information as a security researcher. And if you uh, want to find some other vulnerability, like sometimes in the recon part itself we could gather the information which is disclosed, and it could be a vulnerability. So that type of vulnerability can be found in the mobile applications. Okay, so the first thing is analyzing the decompiled APKs for hard-coded credentials or poor cryptography. So mainly here we're gonna decompile the applications. It's about like reversing an Android app to read its code or resources to find hard-coded credentials, APKs, or weak cryptography functions. So regarding this, we'll be seeing that. And yes, okay. So for this, I'll be using the application that is Injured Android, and I need the command prompt for this. Okay. So in this command prompt, I'll be okay. So I'll also use the JetX tool. So JetX tool is one of the tool. Mainly, it will decompile the secure code, the codes of the mobile application APK. Mainly, it's used for APK purpose. And here also you can analyze these codes. Okay. Here I'll just drag and drop, or else you can use the APK tool to decompile the application itself. APK tool D, and I hope you can see my screen clearly. Yep. APK tool D, that which means we are decompiling the application. Same way, we're gonna give the application name that is Injured Android. This is the application. It will decompile the application where it creates a folder for you. Okay, here it has created the folder. So this folder contains all the resource files, all the content, the source code of the mobile this application Injured Android. Okay, so here I'll also start my uh, yeah emulator for to show you how to find these loopholes. Okay, like this application, it's about just a lab application which I'm going to show you. And yeah, emulator, and here. Okay, this is how we're gonna start our emulator, and mainly this emulator, it's from the Android Studio, and you can also use this emulator from Android Studio to uh, find the loopholes. And it's a rooted emulator, and it is it contain we can it's a x60 x86 64 architecture emulator. Okay, only that type of applications can be installed in this uh, device. Okay, so yeah, regarding I'll be installing that application. Okay, okay, we have this application here, and okay, going for Okay. So here we have to find a flag. Okay, the thing is like we have to find some the in details on this flag. So mainly in a mobile application, it will not reveal like this flag for flag two. It will have its own contents. Like if it contains login activity, if it contains about us page activity, anything, it will have with that name. Okay, and here it just mentions about these activities and flag four. Okay, so here the flag we see that it shows that like when we click on hint it shows where is Bob and we have to find the clear information. Okay, so clear information like we have to analyze our the credentials, okay, API keys or weak cryptography failures on the mobile applications. So by this flag 4 activity, we see that some of the codes where it's like a bit hard to identify what type of code it is and all. And to identify, we have to check each activity where it redirects and all. And we have to check these details, okay? So we it has all the uh, other clicks codes where it will reveal the datas and yeah, we have some datas where it goes for the G class imports and we have to identify the class imports as well. So when I click on the G character where we found this is as this as a code, okay, where it mentions that basics for decoded value. So we have to identify that this is the encoded value where we have to decode this value with the decoder. So you can just check for base64decoder.org and just paste this content and decode the value. Okay. So it shows that for overdone. I mean, this was the flag. I hope so. And let's copy it and paste it in the application and submitted. Okay, it shows that you congrats, you have found the flag. That was the flag. So here the thing is, there was a cryptographic failure on the application. Okay, as we have seen here, we have reassembled the application and we have found that there was a weak cryptographic function on the application where the data which was stored, which is very like which is not encrypted with a good algorithm or good yeah, good hashes and all. Okay, so which reveal this content. Same way we'll going to extract API keys or sensitive endpoints using manual way. So manual way you can check the Android manifest file or configuration files, anything. You can use JADX. That's your choice. You can go for this or your Android manifest file is there. In the Android manifest file, lot of contains the activities which are passing, the user app permissions, all these things. Everything has been written in the Android manifest file. We just have to do a recon on the applications. See, one of the thing is the Android network security configuration at path is there, and something like some activities are mentioned here. And same way we have to check if the application is debuggable or anything, any types of data we can easily find on this Android manifest file. And you can give a try on the same thing that is on the resource libraries as have written in the PPT. It's mainly mentions that those folders like assets, reserve values, raw, anything. Okay, so it will help you to find the unencrypted keys, URLs, debug files. It could leak to some logs as well. Okay, so here just we have to analyze the each resource files, the system files, or anything like in the values we have the strings, anything. In the strings we have lot of characters, any data, the flags, how to do SSL pinning. Okay, just they have mentioned. Okay, see, here we got some API keys. So this is about Google API key. Sometimes most of all the applications will reveal the contents of the Firebase APK, the storage API keys. So you could get these details when you do a recon part. And regarding the exploitation of Firebase, there are like a lot of exploitation techniques are there regarding exploiting the Firebase key or the exploitation, or it could be some AWS keys which is leaking over these strings and all. Okay, so you can do any of the method to find these loopholes on the target. Same way, we'll move on to the next thing, that is automating static analysis with MobSF. Okay, so regarding MobSF, it is a uh, mobile automation tool. Okay, where you could find some of the vulnerabilities on the by just scanning and finding the loopholes directly. Okay, just by it also saves your time by scanning the common security issues, and also gives the permission insights of permissions, how it has been used, code issues, libraries, all the data leaks on the mobile applications. So let's move on to that, and I'll just start the MobSF. So I have directly installed that MobSF on my device. So I'll just start the MobSF. It is hosted in the localhost 8000 port. Sorry for that. Yep. So yeah, now will be you can see this MobSF page, and see I have installed it on my Windows system. And if you are trying to scan the IPA file, it's mainly on the it's about iOS file. It will not scan that your IPA file here. It will show some errors. And if you want to scan the uh, IPA file, you have to run it in Mac OS, or it could be in the Linux OS. Okay, and if you want to just scan the APK file, you can just host it in the Windows OS. It's fine. Okay, and I'll just drag and drop the application. I'll go for the another application, that is Diva. Okay, that could be easy for us. And yeah, so as Diva application is also one of the lab application where it finds the MD5 hashes value, SHA values, and the security score of the applications, all the activities in the exported 17 activities to our exported activities. We can find that services, exporter providers, all these things, and the signature of the certificate of the mobile applications, how it has been signed and all. Same way, the permissions which was given to you, given like it is asking by the application, is it dangerous or not, all this information has been given. Same way, the other application signed with the debug certificate. This is also a lot of vulnerability. If you are not able to exploit this part and all, you can just mention to your the client, or could be the VDP targets where these vulnerabilities has been found in your applications. Okay, just check manually and find these vulnerabilities. Another vulnerability, there is Janus vulnerability, where uh, with the signature of we like a low level signature, it can be exploited these vulnerabilities. And same way, the other vulnerabilities can be found here. And the application is debug enabled. Okay, so if the application is debuggable, where it could lead the application lead the logs of the each data which was running, and it can be reveal some sensitive data over the log files and all. So this type of data, if you find in a mobile application, it's a loophole, and you can definitely report these bugs on the target. See, as I said, when we do a recon itself, we could find a lot of things on the mobile application when we do this testing part. Same way, if you are going for the iOS application, see, iOS, I have an IPA file. If I drag and drop, it doesn't work in the MobSF. So regarding this, I have to make a copy of that application. And yeah. So regarding copy, I have made a copy. So I have to make it as a zip file. Okay, in the zip file, so it will convert it to a zip file, and now we have to extract to diva copy, like where, see, every APK or IPA file is a zip file. Okay, so when we decrypt that and make it as a zip file, we can easily decrypt that, yeah, decompile that zip file, and we can see each components that are available in the IPA file. See, this is the way of how to find the data on the IPA files, and we could easily get the info list files and all. See, here it could have some main the keys or the datas of Android, anything. For this, we need 3U tools on the Windows, or if you are using on Mac OS, you can install 3U tools, or else you need the Xcode for to test on this. Okay, Xcode mainly for iOS pen testing. You need that um, tool. Okay, and you cannot install Xcode on your Windows system and all, and other like images, all these things of that device application has been shown here. See, every path, each, if you go for these checks, it will take a lot of time. Like recording part, it doesn't, it just not a simple way. We have to do a lot of research on the applications to find the loophole on each phase, and we have to do the reconnaissance on the applications. Okay, this way we can do advanced recon techniques on the mobile application and find the correct loopholes on each ways of finding the data on the applications. Okay, so yeah, we'll go on to the exploiting some common mobile vulnerabilities where you guys will have some idea. Okay, these vulnerabilities can be present in the most of our mobile application. You can give a try directly on the mobile application. And let's move on to the first thing, that is biometric root and emulator detection bypass. Okay, so hooking functions using Frida to bypass security checks. So I'll be using the Frida for this tool, Frida tool. Okay, so before that, I'll close the mob SF. Mob SF is not needed, and yeah, we need the two of the command prompt. One is like I need ADB shell to see the files. I need the application name as well. So I'm going to exploit have the another application. Okay, so for this I'll be using first I'll be showing you with the just a second. Okay, I'll be showing with the application that is root detection bypass. Okay, then we'll go on to the biometric bypass and all. Okay, for this we need the Frida code share as well. And Frida code share, where to get the Frida code share, we can easily get it from the browser, from the Coda Frida code share search. Just you have to search on that. And yeah, okay. First thing we need the application name. Okay, so I'm going to test this Android Goat application, and I'll be using the command that is pm list packages. Okay, and I'll be using the grep command to find the application name there fast. And this was the application name, and yeah, that's it. I just want to know the name, and I'll be using the Frida server now. Okay. Okay. Same thing. I have to run the Frida server. The setting of Frida server, there is a long process on how to set the Frida server in your mobile device. Otherwise, you cannot use the Frida server. You have to install. There are ways like use the Frida gadget or Frida server on the mobile applications. Frida gadget you have to inject in your mobile applications directly by reverse engineering the application and all. And regarding the installation of this Frida server on this mobile application, the ways you have to add the get the open SSL certificates, PEM files. You have to install the certificates on the mobile applications as a system certificate, all these things. Okay, so yeah, I just don't want to go on that. I'll just show on how we can exploit the Frida servers. So I have to enter CD. Okay, now I'm in the path. Let's clear this. ls. Okay, we have the Frida server there, and I'll just run that Frida server and start it. Okay, Frida server is running in the background. Now I need another command prompt to show to run the Frida. Okay, so I'll be going Frida hyphen u and hyphen f. Okay, before starting hooking the application, I want to show that, as I mentioned, this application, this device, it's a rooted phone and it's an emulator. Everyone knows, right? So root detection, it shows that device is rooted. One of the thing. Another one is same with emulator. This is a emulator. Okay, everyone knows that this is the emulator as well as it's a rooted device. And I need a Frida code share on root detection bypass. Okay, so you'll get a lot of code share techniques. So these codes are like you can just copy this code, or else you can just use this command of code share to hook the application. Okay, so I'll be using Frida -u to usage as -f as the application. Then I'll be using -f code share of the root detection bypass. So now I have just used this Frida code, and now it has hooked the applications. Now if I check the application, it shows that this application is not rooted. Device is not rooted, and you know that it is a rooted phone. But when by hooked by this Frida code share, it shows that device is not rooted. Why? See, lot of more bank applications, lot of the paid, or if you say the payment application doesn't install, it cannot be installed on our rooted device at all. If you are able to bypass this, and if you are able to install the application or run that application in your device, that means you can report that bug. This is the security testing how we can do on the mobile application. Same way, if you want the Frida code share for biometric bypass. Okay, biomet not the biometric. Like we're gonna see the emulator. Biometric will see later part. Yeah, emulator detection. And there is a field of multiple bypass command is also there. See, lot of codes. If you are good in coding part, you can go for this as well to write some FRIDA codes where you can identify the source code and check how we can write these FRIDA codes here and all. Okay, otherwise you can just use this manual codes on exploiting it. Okay, same way we'll go ahead with the multiple bypass, freedom multiple bypass. It has a lot of bypass techniques. Okay, let's see if it has bypass. Some of the codes here works, but some of the codes here doesn't work. So you have to identify each one of the codes and all. Okay, so now you have seen it was an emulator. Now it shows this is not emulator. This is how we can run the application. Okay, see it shows that device is not rooted. Same way, this are the ways where if you find the applications can be installed in the rooted device or emulator. Okay, mostly that applications, as I mentioned, the bank application or the payment application, it will be not installed on these devices and all. So if you are able to bypass and install on these device by reverse engineering, or it could be in this Frida hooking runtime manipulation part also, it can be reported, and you can uh, provide the client on about these reports and all. Okay, same way we'll go with the biometric. Okay, we have this insecure bank, which is for we have to see no fingerprints enrolled. So here we have to provide the fingerprint for that. Okay, so for fingerprint, you know about biometric codes. So I'll be using biometric bypass Frida course. See, like everything is available in the internet. You just have to research on this content, and you'll get an idea on how to find these the resource, or like how to bypass these codes. Like, see, as I have gone found this application, and I got this idea where you will be able to run these codes by you hooking the Frida and hijack the biometric root detection emulator, anything. Okay. Same way here for this, we need a different application and have to identify the application name. Okay. We need the application name as well. And I'll use it here itself, ADB shell and PM list packages grep. I'll be using the finger, and this was the application name. Okay, and I'll just exit from here. I just have to run that command. So I'll just remove this. See, yes, okay. And I'll specify the application name. Then I'm going to specify the code to bypass the biometric. Let's see if it works. Same way you can try for iOS. If you just research on Frida Kosher on iOS biometric bypass, you can just click on that. If I just click on it, if it shows that fingerprint bypass successfully, that means we have bypassed the fingerprint on the applications. So this is the way of finding the security vulnerability on the mobile application. See, these are security contents, and it has been bypassed with the just simple Frida hooking skills, right? So just have an idea how to bypass this, and it could be easily we'll be able to easily exploit these vulnerabilities. Same way, we'll go ahead with the some other vulnerability, that is SQL insecure data storage. Okay, insecure data storage you have seen in the basic advanced where it was in a plain text. Same way we'll be using the SQLite method. Okay, where the data is stored in the SQLite database, and we can easily get that data. So we'll be using same Android Go to application. So here in the Android Go application, we don't need the Frida anything. We just have to see that we have this SQLite, and I'll be saying saving the data. Rameez, okay, it's not entering the clearly. Okay, Rameez. This is the username and password. Just think that you are entering into one of the mobile application, and it saves our data in our what you say in the storage. Okay, but regarding this, you have to analyze the source code of that mobile application, like how the login activity data has been stored and all. So you just have to open that Android Go, run this code, and you have to check each way of the applications, how the data, all these things, will be stored in the mobile application. It could be through the SQLite database, or it could be through the like just a plain text in the shared preferences or anything. Okay, so you just have to identify that. And yeah, now I'll just save this. I have entered the data, and now we have to visit the same the ADB path of the mobile application. So I'll just access the mobile shell. So I am in the mobile shell access. So I'll be just listing all the files. All the files are available of the mobile device. So I'm in the rooted folder because it's a rooted phone, and data. Then I'll be entering the OS goat. So here we have files like app texture, web view, cache files, database. So we need to enter the database where like no see as the database mentions it could be containing the data. Okay, database information like mainly in the SQLite. So we have one of the a goat file which mentions it could be the database, and I'll be using SQLite 3 and mentions that a goat file, enter. Okay, now we just have to enter the dot tables. It will reveal the Android metadata and users where like we are in the SQL data, and we could see that there are users datas are available. So what we have to do, select star from, then we have to specify as users. Okay, then we have to close it with the inverted comma, and you see we have a username as Rameez and Rameez at 123. So this is the data which was given by the user, okay, which has been stored in an unencrypted manner in the mobile application. So these are the ways to find these vulnerabilities on the mobile application. I'll just exit this. Okay, not way. This way you could easily find these loopholes on the mobile application. Same, we will move on to the next one, that is demonstrating using XSS to retrieve some data from the internal storage. Just as you have seen some data, right, in the mobile application, we just have to enter some data. Okay, see like input validations. We have the input validation. A lot of applications will have these input ways. Okay, and we have the input fields in the mobile application where we can enter a set of details and all. So I'll be entering some data here. Okay, if I just enter, okay, I think I'll just close this. I'll reopen the emulator. So it shows some issues like entering the data and all. Let's see now. Validations, it's not clear. Yep. I'll start once again. Okay, let's open now once again. I'll just let's see if I'm able to enter some data. Okay, it shows the same thing. Okay, I'll just enter here itself. Comma with the script of XSS, as we know that. Okay, I'll just go ahead here itself. Okay, so I will be entering this script code. Okay, it's mainly about XSS. A lot of researchers know about this, and I'll just paste that code here. As you can see, we can see a JavaScript input validations is available on the application which is insecure. Okay, we could create a code where it could reveal some data. Like if I'll just enter my pseudonym like show off, I'll just enter here and I'll just paste this code. So okay, I think I have not closed it, so that's the reason. And you see, okay, we have found that the access vulnerability is present. And regarding this exploitation, okay, we just have to add some server of the codes, and it could reveal some more datas, like it could send you cookies of the mobile applications to the attacker. And regarding the demonstration, you just have to add some the server URLs, and which could reveal the cookies of your mobile applications data and all. Okay, so this is how you can easily find this vulnerability. And let's move on to the another exploiting common vulnerability, that is capturing and manipulating app traffic using burp suit. Okay, so most of all, everyone loves to bypass OTP, and or it could be through session manipulation. So we'll be using some live applications on that. I'll just set up the burp suit for that. Just a second. I will be using, okay, my applications here. Proxy, okay, it's sorted out, and no need of, I think Frida, if it is needed, we can just configure it, because let's see, we'll be going with the cake application. Let's see, we are able to capture some request of this. Okay, I'll just enter some day mobile number. Okay, the mobile number is about, yeah, this is a mobile number and login. Okay, we are able to capture this request. Let's see where it sends the OTP. Okay, it sends the OTP. OTP sent successfully on your phone. Okay, this is the response code, right? On the mobile number. And let's see, now we have to enter the OTP. See, regarding OTP, we don't have the OTP. What we can do, we know how we bypass the applications in the mobile in the web, right? Same way we have to identify the capture the request, then do intercept on the request. And let's see, okay, we got the bad request. That means the application code is wrong. So what we have to do, we just have to change the response. Okay, send it to true, code as to 200, then forward the request. And yeah, we got the application, and now we are logged into the application, that caking home application. So just by skipping the OTP, just bypassing the response manipulation on the target, we could get the access to dashboard. With this is not my account, this is just an account of other users. Same way, if I want to try with the another applications, that is third wheel. Now it's from the from the Nepal application. Let's try on this. Okay, here we have to add the mobile number. That is, we'll just add that mobile number. Five, and I have to enter the mobile number. Like their mobile number is different from India, and like it's also 10 number, but like if you enter some other numbers, it will not validate properly. So click on next. Okay, now let's see if it leaks the OTP in the response itself. Sometimes some of the OTPs could be leaked in this response itself, and you can just check this token as well, where it could leak more data and all. Okay, now I think data is not there. Let's move on to this, and already sent to, okay. If you didn't get, please again 2.5 minutes. I'll change the number. Less 958 58 6358. Okay, shows a different phone number. Okay, 558 358. Okay. Okay, let's go on to the another another one, that is with the email address. You can try with the email address or phone number, anything. Simple. I'll just go with the mobile, my email ID at gmail.com, and I'll click on next. Okay, it is sent. It has sent the application like OTP for my mobile, my email. Okay, and so now I don't have a OTP right now. Okay, if I add the victim's email also, it will just send that, and just now I have to verify the OTP. So what I will be doing, I'll just do a response manipulation on the same thing. Just make it to true. That's it. These are simple vulnerabilities, can be found in the mobile application. Lot of, see, web, some of the web applications it can be provided, but a lot of mobile applications by this OTPs bypass on, we can easily find in the mobile applications. Okay, just I just bypassed it, and we got once again to false to true. That's it. Okay, now I just have to create the new password and enter. Okay, some password enter. Fine. Then now just enter your user name, phone number. Then you can easily create this account. That's it. This is how we can easily bypass the applications by using the OTP bypass method or response manipulation method on the mobile application through Burpsuit. And another thing is the tool which I mentioned, that is Browser. Okay, so for Browser you need both of the client as well as the application which you have to install in your device as well. So Browser agent, I have installed it here. Just I have to on this Browser application. Same way I need I'll just and exit it. Okay, and yeah, I have to specify browser console connect. Okay, I have to enable it and I have to on this. Okay, sometimes it will not connect because we have to specify that we have forwarding the request from TCP IP, that is 31415, which is mentioned in this server. Same way we have to specify for that, like we are passing the request from. It is also works as a burp suit with the agent tool. Okay, now we'll connect the browser console connect, and now browser is connected. Okay, each application can be tested through browser, and we just do ls and lot of tools, lot of scanners, information exploitation, app information, everything can be found with the browser. Okay, so I'll just go with a simple way where we could exploit content component. Okay, we have seen the in the basic. I hope Kuldeep has shown you like how we can hijack the through the ADB shell. Okay, now we're using with the activity of browser, and we just have to specify run activity -a and the application name, that is OWASP board. Okay, this is the application name, and we see we have two of the applications. So here we have to specify a pin for this to view this the inside content. Okay, if we have a wrong pin, and it will not allow incorrect pin enter. Okay, so we have to bypass this pin application this pin activity. Okay, so regarding that we have to use this activity of browser. For that we have to specify run, and there are like a lot of options are there. If you want to know more about it, you can just check out about the browser tool, and I have to use this app activity of browser and specify run app activity. Then with the hyphen component part. Okay, component we are which component we are going to exploit it with the OWASP application name, the same way with the activity name. That's it. And you see now we got the access to download invoice. Now invoice is being downloaded. So we were not able to view that content. So the real password is uh, just a simple password which I entered. Okay, without this pin we are not able to pin verified. So if I try to enter some other data here and try to get the invoice file, it will show pin incorrect. With this the way of bypassing the components, or it could be activity, just revoking that, we could access the inside content, and this way we are able to exploit these vulnerabilities. This is how privilege escalation where browser can be done in the application and get the access to that. So the another thing is we have the code tampering. So code tampering, it's about modifying the APKs to alter app logics and bypass restrictions. Okay, just for this I'll be having another application for you guys. So I'll be using, yep, this application. Let's install this. You see, this is an application, and to log in, you need the username and credentials. Okay, you are not able to view the content, nothing. So you can use JADX or else you can use the APK tool. So I'll be using a APK tool for this and to identify the content. I'll just close the browser for this and just clear the screen. Okay, we have the application there. I'll be decompiling that APK tool, decompile, and I'll be using the application that is yeah, so insecure bank v2, and it will decompile with the folder path, and we can easily get this. Okay, so we have this folder path, and you see it is decompiling the application. It will take us a bit of time, and same way I'll be using JADX for this to show you how to identify like what is there, how we can reverse engineer the application and get the create user amount option here. Okay, and regarding that, how to need the application on the JADX, and yeah, in the JADX we have to check the application uh, codes and all. Okay, so we have the code here, change password, post login, login activity. Okay, in the login activity, we have the password. Okay, we have the username button, we have the login data, fill data, login data. We have another button that is create user. So we can see that there is a button where we can create a user by this application. So regarding that, how to we can get the data? So we can easily get the data by just doing a reverse engineering on that application. Okay, now let's see if it is decompiled or not. Okay, the application has been decompiled and we have these files. Okay, so we have to check each one of the things how the data has been created. So we have to find the value where we could change the data of the applications. Okay, we have this application, and this was the string file where it shows that all the login screen password where it have these data and all. So I'll view it in the as a notepad, so we can easily check that. Okay, so there are like a lot of things. So we have to identify that I have seen something. Okay, it is admin or no. Okay, it shows that if this application is admin or not. Okay, so we have to change a single thing here on the application that we have done it is no to yes, and we will save the strings file. So that's it. We have changed that. So where we after making the application to admin level, we it will create a user button for us. Okay, now we I have to combine this application with the APK tool itself. Same way we'll be using, you can use the APK lab as well. For that you need the Visual Studio Code, and APK lab it is a good extension from the Visual Studio where you could combine and decompile and compile the application easily from that. Okay, so yeah, APK tool and specify the application name, the build, your specify build, then your specify insecure bank, the application. Okay, then hyphen o with the ibank dot apk. I'll specify like this, and now here we see we have seen that the application doesn't have a create user button. Now I'll just delete this application. Okay, we don't need that. We have creating a new application, so it will just take us a bit of time to compile these all the resources. Then will try to install it. Okay, so there is the issue on that when if we try to install these applications on the mobile application, yeah, in the mobile device. You see this is the application. If I try to install it, it shows this error. Okay, because the application is not signed. So to sign that, you have to use key store, you have to use jar signer, you have to create the like zip align the application, all these things. For that, to bypass all these things, we can use one of the tools, that is Java Uber APK signer. Okay, this is one of the jar file which will help you to sign the application, and just you have to specify with the Java hyphen jar and APK Uber APK signer with the hyphen hyphen APK command. Then you have to specify the application, that is iBank. Okay, now it has been merged and we have the iBank application with the signed.apk. Now we will try to install it. Okay, it has been installed. Let's see the application, the same application. And you see here we have the create user button. So what we have done, we have changed the application to an admin level application where we could create a admin like create the user on the application, because before when we were trying to install it, we couldn't do that. But as we change the some value in the strings, or it could be in the code, we are able to get the admin access and create some other users. Same way if you are trying with the other mobile application, it could be the VDP, it could be the hackathon, backrot, client targets, anything. If you just see this admin level access, you just have to research on this on the through JADX, or it could be through the APK tool, just on the grep command. you could find some logics, and you can just alter that logic and bypass the restrictions and get the admin access on the mobile application. This is how common, like these are like some of the vulnerabilities which you could exploit on the mobile application. And yeah, so we'll move on to the reporting and compliance part. That's the live demo on the exploiting common vulnerabilities. Let's move on to the reporting and compliance part. So reporting, it's about where it will help the developers, the managers, or it could be stakeholders. So how the vulnerability has been found, with the impact and the fix. So in the report, what to include: vulnerability title, description of the issue, impact and risk level, like it could be the critical level, high level, medium level, low level, any types of level, the vulnerability it contains with the impact as well, and the steps to reproduce with the screenshots of POC, and the affected components like code files, where it has been affected, which type of files, the string files, it could be the Android manifest file, any types of files where it could leak the code, and recommend some fix or mitigations on how to fix that. It could be the client mainly, you have to provide these fixes. Yeah, so that's now you have to report that, and aligning the reports with the industry standards. Okay, the compliance part which I mentioned, it's mainly on the thing where you have to follow these standards. Okay, so OS per mass VS, it's mainly mobile application AppSec verification standard, where you have to use a checklist to categorize issues under like authentication. Like if you have find the OTP bypass, it comes under authentication. If you have find that the data is not encrypted, it comes under a cryptography part. Same way with the storage, where it's like your data storage vulnerability is present. So we have to analyze with the standard part, and you have to categorize the each vulnerability. And also by this standards, it will help us the standardizing the test coverage, what type of coverage we have to do, where to test. It could be the login page, or it could be just the storage part. Only it will have the standard, and we can specify the clear reporting format on the mobile application. Okay, when you do a report on the found vulnerabilities on the target. Same way we have the report alignment, which mentions the mass VS control, which is all violated with the mentioning with the names and all. Okay, so mass TG storage one has been, if we can mention with that standard, like where these vulnerabilities has been found and all. Same way we can follow with the GDPR, that is the General Data Protection Regulation. So like we have to follow these standards, like required for apps collecting data from EU citizens, like how the data has been collected, all these things, and report any vulnerabilities involving PII exposure. Okay, so any data, if it is leaking, the email, name, phone, etc. on the mobile device, or it could be in the logs, it could be in the storage, or it could be in the source code of the mobile application, everything should be mentioned in the report by this industry standard. Then we have like clearly mark data leak risks on the compliance part, the measures, data encryptions, consent forms, all these things we have to follow this standard, and specify how these vulnerabilities, the leaks has been, the risk of the data leak could be occur. Okay. Then with the PCI DSS, it mainly for the payment card industry data security standard, where see each application, the payment application should follow these PCI DSS standards. And if we have to, this will be applied for the app stores that process transmits of their card data. Mainly it could be the payment on credit card, phone pay, all these applications are the Google Pay. You know about these applications, it have to follow these applications. And if you find these of the applications which will leak the unsecured transmission of the data, storage of CVVs, or weak encryption of data is be stored in the in our mobile storage. So you can specify these vulnerabilities on the uh, report. Okay, so by the following these standards, you could easily for explain, I didn't mention that the standards can be specified, and how the vulnerabilities and exploit goes against these standards and all, you can specify that. Okay, and yeah, same way with the maps finding to PCI DSS control failures, mentioning that things on the report part. So it will align the report with the clear set, and you can easily specify it to the client on these standard part as well. Okay, so yeah, so that's about the advanced mobile penetration testing. I hope you guys got some idea on how to test the mobile application, and you need some tools on that. Okay, and the tools, everything is mainly needed, as I've given some tools in introduction as well. And yeah, so as a career path for mobile penetration tester, you who are willing to do a cybersecurity and you want to be a cybersecurity expert, okay, you will get some entry level tasks. Then you will have the advanced assessments on the testing part. Then you will be moving into the specialization of each deep dive into the pen testing part. Then same way you'll be collaboration and reporting part of the with the higher team members and with a good collaborating with the other peoples and all. Same way, you will be getting the continuous learning if you are going for the advanced like path on learning the mobile penetration testing and the stages as we if you're if you are a fresher in the cybersecurity field, the education like you should be graduated IT. If you are in the background of IT or computer science, anything you can get for some low-level cybersecurity jobs like vulnerability tester, cybersecurity analyst, security auditor, cybersecurity sales, junior pen tester, all these roles. Then, as per when your skills has been improved, as well as if you have good idea on the on uh, s- the idea on the tool testing and all. So you'll be upgraded with the advanced generalized like cybersecurity specialist, senior security analyst, as well as senior security administrator. Any types of job roles which you could get in the career of cybersecurity. And same way with the stage five, we have the governance part. Will be the chief privacy officer, cybersecurity lawyer, cryptographer, like a senior security architect, senior risk advisor. A lot of roles are available in the cybersecurity, and you could be level up each way where you get an idea or learn these advanced skills on cybersecurity as a mobile pen tester, web pen tester, any types of roles which you learn. Okay, so that's it on my webinar, and I hope you guys have loved and learned something on the mobile penetration testing. And if you have any Q&A queries, you can ask. And Saurabh, I have done with the webinar. Saurabh, can you hear me?
Yes,
Yeah,
Ramesh,
yeah.
I'm here. I'm here.
The webinar is done. We'll move on to the Q&A. Before that, if you want
Yeah.
to say
No, no,
something.
no. We just we'll just give them 2 minutes till by in the meantime you can have some water. Okay. That was really
Yeah,
a
yeah, fine.
very insightful session. Okay. So just turn off your camera, have some water, and guys, meanwhile, you if you have any questions, any queries, do put them in the Q&A section. Okay. So we have if you look on the top corner, okay, you'll see the fourth option as Q&A. Okay. So just go there, post your questions there, and once Rameez is back after getting refreshed, he will answer all the questions that you have. Okay, so it was great and informative session, sir. So Rameez, it's for you. Thank you, guys, for such insightful comment. And okay, this is an amazing session. Is it possible to have a list of tools and Android environments used? So I think this is something that Ramesh can share. Okay, so if you guys, I can see some people have requested for the presentation as well. Okay, so what we'll do, we can share this presentation link in the YouTube video that will be posted next week, most probably by Wednesday. This video, present masterclass video will be posted on our YouTube channel. From there, you can watch the whole presentation if you want to rewatch it again and download the presentation from there itself. So, guys, again, I'll repeat if you have any questions about the presentation, about the mobile penetration testing, please post that in the Q&A section. Guys, please do
Yeah,
not comment. There is a Q&A section for that. Okay, I think everybody is commenting, Ramesh. Okay, so no
okay,
worries.
okay. It's
Uh,
fine. Some questions like regarding the tools that were used in the
yes,
for testing purpose. I hope the tools it's just a you can get it from Google itself. Like it's our Also, if I want to share the presentation, okay, I hope it's there. Okay, I hope you guys can see the. So yeah, these are the tools section. The names which I mentioned, yeah, these are the tools. Okay, so all these tools, everything can be get it. You can get it from the Google, and all these tools are available from GitHub, and you can easily install these tools on your device. Okay, so you can just take a screenshot on this if you need the information on tools. And these are just some tools. Okay, there are a set of tools which is mainly needed for a mobile penetration testing, and the best where we can use it for a basic not a basic, it's an advanced level testing and all. And you can also use a micro MSF console. As you know, the Metasploit, there are some method where we can use MSF console to exploit further on getting the access and all. Okay, which emulator to master mobile pen, how often do I need to practice? Okay, so the main thing is you have to understand the flow of the applications. Like if you have good idea on the web pen testing, it's easier for you to learn and do a practice on the mobile pen testing. The thing is, like here, one of the thing you have to identify the static analysis, where you have to check the source code and identify how the code has been written. So based on that, you have to more on that. And so which emulator you have used? So I have used the Android Studio emulator, and yeah, Android Studio you can use it. And also there is another one that is the Genymotion emulator. You can use that emulator as well. And for downloading a APK, which website is good? You mentioned yeah, regarding app website, you can use APK Pew, or else you can download it from Play Store. Okay, if you're downloading it from the your what you say, like your physical phone, it will be, you will not able to run from in the emulator and all. So for that, you can go for the Android Studio Play Store applications. You have to build a Play Store emulator. From that, you can download the application from there. Okay, so yeah, what is best vulnerable APK to cover all vulnerabilities one application? See, regarding best vulnerable APK, there are like a lot of applications. Okay, just to mention, we have Diva, we have DVBA, we have insecure bank, we have injured applications. Lot of applications are there. So some of the applications I have here, like one is yeah, this insecure bank application, Diva application. We have the Android. These are applications which are very useful for you guys to learn the on the mobile pen testing, and you'll be able to identify these sections. Okay, so can you tell me how mobile pen test can help in SOC? So regarding okay, mobile pen testing, it's mainly comes under VAPT part. Okay, regarding SOC, you can just analyze the logs of the mobile applications, like how the data has been logged in the mobile applications. So just to analyze the logs of the mobile applications, if you are using in the company environment, and to identify what data has been risking, which website you are using. For that purpose, just to connect with that, we can go. It will help for SOC itself. Other than that, mainly pen testing, it's for VAPT, like to find the loopholes and vulnerabilities in that. Okay. And YouTube channel link, name of channel, you can just check for that. CyberSapiens in your YouTube. Just you have to search in your YouTube. Okay, you'll just get the idea of CyberSapiens. I think CyberSapiens. You'll get the lot of videos in the from our last yeah, masterclass as well. Okay, just view that. Sapiens. The spelling is missed out. Oh,
Ramesh, I've already shared the link. Okay.
okay, okay. I hope you have shared
Yeah.
it. Thank you, sir, for that.
Yes.
And any other comments we have? Questions? Okay. So for Android pen testing, do have learn programming language is used for development? Mostly, so just a basic idea on the programming language, mostly Kotlin, Java. It's nice to know that. Okay, so if you have the basic idea on that, so where you could identify source code. Otherwise, just you will have the dynamic testing part. because like with the for static analysis, you have to know how the code has been written, how the data checks, how the data has been passing, how the database has been created. All this identify you can have to identify through this JDX tool and all. So where you will be able to find some idea how the logic creates and all. Okay, so I hope just a basic idea on the programming language it's needed, and what is the best emulator for iOS. Okay, so for iOS, most of all, everyone needs the emulator, and for iOS emulator, you have to pay. That is a Corellium emulator. Otherwise, you need a physical device. Okay, physical device because see, iOS you cannot test on. You don't have a clear emulator for that, and you just need an emulator. One of the emulator that I have mentioned that is Corellium, which you have to pay per hour for each usage. And I think I like no need of you going for that. If you have an old iPhone, you can test on it. No need of like regarding iOS also, you need a lower level of iOS version because you have to do the jailbreak and you have to do the testing on that application and all. Okay, and any other doubts, queries, any more queries, guys? Most of all, everyone wants the YouTube link of CyberSapiens.
Yeah.
Okay, Saurabh has been
So
shared that.
yeah. Yes, Ramesh, I'm audible?
Yeah, yeah, you're audible, Saurabh.
Yes, yes. So I think we have no questions. Okay, not any more no questions we don't have. So I think we can. Okay, and there is one question. If you look into the Q&A section, one
Okay,
last
okay.
question.
So here, can we practice Android pen testing OS top 10? Yes, you can just practice on OS top 10 vulnerabilities. See, for Android pen testing, we have a lot, not for Android, it mentions about a mobile pen testing OS, mobile top 10 vulnerabilities. So you can test on a lot of these the labs which I shown here, right? Which I had like this Android Goat, or it could be the injured Android. You can just test on that, and you can learn some practice and find these loopholes, and you can master on that for finding these vulnerabilities and all. I hope so. Everyone got the queries.